Alright, today's video is going to look at Rolle's theorem, and you'll find out with Rolle's theorem that this is more of an existence type theorem, and it states that let f be a continuous function on the closed interval from a to b and differentiable on the open interval a to b. If f of a equals f of b, then there's at least one number c in the interval from a to b such that the derivative equals 0. So that's f prime of c equals 0. Now if we look at the graph here, what does this really mean? Well, it tells us that if our function is continuous, so you'll notice here we have a continuous function, this nice smooth curve, that between the interval from a to b, and of course this is a nice smooth curve, so it is differentiable. Now, does f of a equal f of b? Well, here's a, so over here we would have f of a, and if this is b, clearly that's going to be equal to f of b. Okay, so we know the function is continuous, it's differentiable, and thirdly, f of a equals f of b. If you have those three conditions, then we know there's going to be at least, okay, keyword is at least one number in the interval where the derivative is going to be equal to 0. And if you think about this, it should be pretty obvious, because if this is continuous, that means there's no breaks or gaps in your graph. And if it's differentiable, then if f of a equals f of b, then that means that eventually, if your graph goes through this point here at A, the only way that it can be equal to f of b is if your graph, in this case, goes up at some point and comes back down. So if that's the case, then that means at point C, eventually where it curves, we're going to have your derivative equal 0, because we're going to have a horizontal tangent line. So we would end up with f prime of c equals 0. So in other words, once again, that would be finding that critical number. So again, really this is just an existence theorem stating that this c value here is going to exist if all three of these conditions are met. Now if we look at the second graph here on the right, we have a graph that is continuous on the closed interval from a to b. Now, because this comes to a sharp point, we do not have a horizontal tangent line. So here, the derivative is undefined. However, if we kind of overlook that condition here with the derivative, then we will realize that there is still going to be a value c within the interval from a to b, because if, once again, f of a equals f of b, with this graph being continuous, we know eventually the graph has to come back down. So that means we're going to have a point that a turning point in the graph, so that our graph will come back down through point B. Okay, so let's look at an example. There's not a whole lot to this theorem. Again, it's just kind of proving there exists this number in the interval from A to B. So let's look at an example here. They state that if Rolle's theorem applies, we want to find all values of C in all values of C in the interval A to B such that f prime of C equals 0. And for this problem, we're going to make our A and B value 1 to 4. So we want to look at the interval from 1 to 4. So first we need to see if all three of these conditions are met. So first of all, is the function going to be continuous? Well, if we recall, this is x squared minus 5x plus 4. We know this is a polynomial, so that's going to be a nice smooth curve. In this case, it's going to be a parabola. So the answer is yes, it is continuous. The second thing we have to look at, is it differentiable? Well, once again, because it's a polynomial, it's a nice smooth curve. There's no sharp turns. There's no holes or gaps. So yes, it will be differentiable. So the only thing we have to check now is, does f of a, so f of 1, does that equal f of 4? Well, if we plug 1 in, we get 1 squared minus 5 plus 4, which is going to go to 0. And if we plug 4 in for x, we get 4 squared minus 20 plus 4, which also equals 0. So we meet all three conditions. So that means Rolle's theorem applies, and what that means is simply there's going to exist a value c. So there's a number between 1 and 4 where the derivative is going to be 0. And really, what does that mean again? If the derivative is equal to 0, that tells us there's going to be a value where we have a horizontal tangent line. And of course, we would really know this because this is we know the graph here, x squared, is going to be a parabola that opens up. So we know there should be, or is going to be, a horizontal tangent line here where the derivative is going to be 0. So really at this point we simply look at the original function and we take the derivative, which would be 2x minus 5. And like we did before, we're going to set this function equal to 0. And if we solve for x, 2x equals 5. So therefore x equals 5/2. So once again, this is our c value. In other words, this would be our critical number. This is where the graph changes direction at with our horizontal tangent line. So this is the c value that we're talking about between a and b. Okay, so really not a whole lot to Rolle's theorem. Just realize if these three conditions are met, that just more or less tells us this value here does exist. Okay, let's look at one more example. F of x equals 3 minus the absolute value of x minus 3. And if we look at the three conditions, and if you're not familiar with this graph, if you put this into your calculator, the graph of this function is going to look something like this here. Let's see. If you remember, absolute value is going to have a V shape. The negative out front says it's going to open down. So our graph would look something like this here. And we're looking on the interval from 0 to 6. And let's see, this is probably more or less going to be like this. Let me redraw the graph here. It's going to go. And first of all, is this going to be continuous? Well, of course, we know it's a absolute value. It's going to be continuous. There's no gaps. Is it going to be differentiable? Okay, here's the question is no. It's not differentiable because here at this point we have a sharp turn. And remember, if we have a sharp turn in the graph, it is not differentiable. So in this case, Rolle's theorem does not apply. And what that really means is it doesn't really guarantee us a point, a c value in the interval from 0 to 6. So here's an example where the theorem doesn't apply, because remember, in order for Rolle's theorem to apply, we must meet all three of these conditions where it's continuous, differentiable, and f of a equals f of b. So if one of those conditions is not met, that means the theorem does not apply.